Okay, so let's do a little recap of the last lesson. So when we think about hyperbolas, when you're drawing in a hyperbola, I really like to think of it as like a 4-step process. And so I just want to quickly make sure that you've got those steps. So step 1, when you see, well, actually, let's actually do 2 things at once. Hyperbola standard form. So hyperbola's standard form is y a x plus p plus q. Now, that is the standard form of a hyperbola. Now, you may recognize it if I put numbers in there. So something like 2 over x minus 3 minus 2. That would be an example of a hyperbola. Now, if we were going to draw that, we would start by looking at the a value. And in this case, because it's positive, that would tell us that we were going to be in these 2 quadrants. Then the next thing we looked for were the asymptotes. Okay. And in this particular scenario, the asymptotes would be, in this case, it would be x would be 3 and y would be minus 2. And those are like the dotted lines that we draw to allow us to almost know where to put our hyperbola graph. Then after that, we would find the x-intercept and we'd find the y-intercept using the same methods that we would always use. And then the 4th part would be to actually draw the graph. Okay, so whenever you do a hyperbola, those are the 4 steps you're going to have to do. You also need to realize that what basically the P and the Q are doing. So the Q is shifting the whole graph up or down. In this particular scenario, it's shifting it down by 2 units. And the one over here, the X, the bit that's changing here, this is shifting the graph horizontally. But what's always a bit tricky about the hyperbola or the X shift is when you see a minus 3, you have to know that this is actually shifting the whole thing 3 units to the right. So it's not to the left. And this happens in parabolas too. The horizontal shift always is a bit tricky. So just to remind you of that. And so those are the basics we spoke about in the previous lesson. Now today, we're going to talk about something called the axis of symmetry a little bit. And I just wanted to show you kind of an axis of symmetry as a brief kind of warm-up before we do a question. So in this example that I made up, the asymptote for x is 3. Sorry, that's going to be the y. It's the wrong one. Let me slow down for a second. So I'm just going to actually draw in this example graph for you quickly. So x is 3 would be like that. And y equals minus 2 would be something like that. Now, I don't know the x and y intercepts. I haven't worked them out, but I do know that the graph of the hyperbola is going to look something like that because it's in quadrant 1. And then over here, it's going to look something like that. So that's the rough hyperbola sketch, basically that we needed to do. Now, what we spoke about briefly in the last lesson, but we didn't talk too much about it, was the idea that there's an axis of symmetry for a hyperbola. And the axis of symmetry is not the same as the asymptote. It sounds like the same, but it's not. The asymptotes are these dotted lines that are basically like, they're perpendicular to each other. And they have this point over here in the middle that's quite important. The axis of symmetry is actually going to be a line that goes like this. That's the one axis of symmetry. It cuts it in half. And then the other axis of symmetry is going to look like that. And so there's actually 2 axes or axes of symmetry for a hyperbola. Now, the good news is the gradient of the one axis of symmetry is always just going to be 1x, or it's basically just going to be what we call x plus k, where k is some random number that we have to figure out. But the gradient is always 1 of the axis of symmetry that's sloping to the right. And the gradient of, in fact, let me not even make a fancy formula. Basically, we know the gradient of this line here is 1, and we know the gradient of the other axis of symmetry is going to be -1. However, that will always be true in hyperbolas. But the problem is we need to figure out the equations of these axes of symmetry. And I only have the gradients. If only there was a point on the axis of symmetry that I knew about. Can anybody suggest a point that maybe I could use to help me find the equations of these two green axes of symmetry? I'd love to hear from the class. Okay, so one of the Nontokozo was asked, how is the gradient of the green one -1 or 1? Whenever you have an axis of symmetry with the hyperbola, the good news is, Nontokozo, is that the one that is going up to the right will always have a gradient of 1. And the one that's going to the left will always have a gradient of -1. That is true for all hyperbolas everywhere. The problem I have is some questions ask us, how do I find the equation of the hyperbola, or the axis of symmetry? And if I only have the gradient, it's not enough. I need a point that's on the line. Yes, Loretta, it's the asymptotes. Where the two asymptotes meet, that the axis of symmetry will always go through that point. And so the point that I'm going to use to help me will just be the point 3 minus 2. So I need to find the equation. Let me get my highlighter out. In fact, I want you guys to do this for me. I want to first find the equation of this line over here. And you know, you have a point on the line, and you also know the gradient of the line. So I just want you to figure out what I call the positive axis of symmetry. I just want you to figure out this one. If you can do the one, you will be able to find the other. But let's just do that now. So I want everybody to use your straight line formula knowledge to figure out the equation of the line that is written in yellow. And you're going to use what's on the screen. So over to you guys.
Let's do this, my people. Let's do it.
Let's think what we know about straight lines. I know all straight lines are like that. Now, can we find the equation of this straight line? So when I did straight lines in functions, I'm pretty sure I always started by just writing out the gradient. There's two methods. And then I would write the point I was going to use. And then I think I subbed that point somewhere. So let's see. Okay, I see some answers coming through. So if we sub, we must be careful that we put the right things in the right place. But what I see is that the equation of the axis of symmetry, the positive axis of symmetry, is going to be 1x plus 5 or x plus 5, y equals x plus 5. And so obviously that was just using the idea of a straight line. So whenever you have to find the axis of symmetry of a hyperbola, you really have to go, first of all, you have to find this place where the asymptotes meet. Once you've got that point, you know that the gradient will always be +1 for the one going to the right and up and to the right, and the one that's going to the left, or the negative axis of symmetry, all that happens for that is that you will still use the same point, 3 minus 2, except now the gradient in your formula will be different. How do we get y equals x plus 5? I don't understand. So what we did is we wrote down y equals 1x plus c to start with. And we knew the gradient was 1. And then we came along and we subbed the point 3 minus 2 into that. So you'll notice that the 3 is the x. It goes here, and the minus 2 goes here. And then what we did was we solved for c, which was that one there. Okay. So if you need to, take a screenshot of the screen now. That was just our little sort of, not a warm-up, but I really know that in the previous lesson, you asked about how to find the equation of the axis of symmetry. And it is a question that comes up in exams. Oh, sorry, it's -5. You're quite right. I made a little mistake there. It should be -5. Thank you very much.
Take a screenshot. So this was just a recap of what we did last week. I mean, on Monday.
Yeah. So just have a quick look there. I see lots of people have noticed it's not +5. It's going to be -5. Sorry. And that was my boo-boo there. Okay, so take a screenshot, and then I hope that clears up any confusion. So is the second one m equals -1? I haven't worked out the second one to causal, but you're on the right track. Yeah. Okay, let's go to an old exam question. So what I want you to do is I want you to do the following as best you can, and I will come along and do bits of it with you as we go. But basically, this is your question. You're given this function, y equals 1x minus 2, and you have to determine the equations of the asymptotes and the coordinates of the x-intercepts, and then you have to sketch the graph, and then you have to answer these questions. Now, let's start by just doing A and B. Let's start by doing A and B. For those who feel very comfortable, you can go ahead and sketch the graph, but let's try and find A and B first. Okay, so over to you guys. Let's do this.
We can do it, guys. We can do it. Remember, this is an exam question, so try and understand it and write it down. So I hope you, Emmanuel, I see you over there. I hope you have your pen and your paper to write down things.
So I see lots of people have written there, x is 0 is the x asymptote, and y equals -2 is the y asymptote. Okay, now we've got to try and find the x-intercept. So whenever we find the x-intercept, we have to remember the rule is the same for all functions. We just need to make y equal to 0. So we can start by doing that, but now we still need to solve that equation. And how can we do that? I think we need to move this 2 across. If we move it across, we get 2. And then I think what we need to move the x across. So let's have a look. If we do that, we get 2x is 1, and then we get x is a half. Okay, fantastic. All right, sketch the graph for me. How do we get the coordinates? So, oh, sorry, the coordinates. Okay, for the x-intercept, you're right, I should write full coordinates. So I'm going to write a half, and the x-intercept is always going to have a y-coordinate of 0. You'll see that in a moment, but basically wherever it cuts the x-axis, the y value is 0. So what I want you to do now is I want you to try and sketch the graph. I want you to try and write the domain and range down. And then lastly, we're going to talk about the, well, let's just do that first. If you have a question, don't be afraid to raise your hand, and you can just come online, and then we will, we can discuss it. But for now, we're sketching the graph. Ooh. So we know actually something I'll point out is that there's no y-intercept in this graph. So normally when you find the y-intercept, you make x 0. But if you put x as 0 into this equation, you would get division by 0. And so that's not allowed. So there is no y-intercept for that graph, this graph. So have we got all the information we need? I think we do. So let's sketch our graph. I see some domain answers coming through. So let's have a, let me just try and draw this as we go. So where are my, I basically only have, let me do my 4-step process. So step 1 is a positive or negative. It's positive, so it's going to be in these quadrants. Step 2, I've got my asymptotes, and I'm only going to have one asymptote, which is y equals -2. So the whole graph is shifted down. And then my x-intercept was over here at a half. Now, it's not a perfect thing. So I'm going to have that. And I'm going to have that. And this number over here is going to be a half. So that is what my sketch graph is going to look like. What is the domain and range going to be? So let's have a look at that. We did this in the last lesson. So domain and range. So domain, x is any real number, but x cannot be equal to, what can it not be equal to? 0. And so that's because we always look at where the asymptotes are. The graph isn't allowed to go where x is 0, and x is 0 is just this line. And then the range is going to be y can be any real number, but y cannot be equal to -2. And that's because the graph cannot touch that, the dotted red line over here. I don't want to make it too busy, but basically it can't touch that line there. Yeah. Okay, so now the task for you guys. You need to find me the Let me try that again. You need to find me the equations of the axis of symmetry. So there's the one. And then there is, oh, sorry guys, there is the other. So it says, find the lines of symmetry which have this form. And I want you to use your knowledge of what we, earlier example, for both positive and negative one. You may spot a little shortcut though, because what is the point? What is this little, I suppose it's a little bit easier in this case. I want to know what that little coordinates are. This is a little bit easier. You guys are good at this. So let's just make sure we've written down this point. What is this point where the two asymptotes meet? It's going to be the point 0, -2. And so because we know what this point is, this point happens to be the y-intercept of both of the red lines. So I'll wait a little bit longer to see what other answers come through in the chat. But guys, what's really nice about this is you know the gradient of this one over here is 1. You know the gradient of this one that's sloping down is -1. But now, if I look at this, you also know the y-intercept of both of these lines just by looking at the graph. So let's see what you say about the lines of symmetry in the chat. Okay, they're not both x -2. There's a difference. They both have a y-intercept of -2, but they look slightly different. So I want you to write them down in their full form. So one of them is y equals x and then something, and one of them is y equals -x and then something. So be careful. The one that's got a positive gradient goes up to the right. So that's this one over here. So the first one will be y equals x -2. So Vukulo, we can substitute, but in this case, because we can actually see the graph already, if we wanted to substitute, what would happen is we would have this, and then we'd have the point 0 -2. And when we sub that point 0 -2 into the graph, right? So we sub it in, we go -2 equals 0 plus c. What you notice is that you're going to get c is -2. And you knew that because visually, you know c is the y-intercept. And so we could see that it was at -2 on this line over here. Okay, so we're using a bit of a shortcut there. So I just wanted to guarantee that the line with a positive gradient has a gradient of +1, and the same for the line with the negative gradient. So Dawn, just to summarize, the lines of symmetry of a hyperbola, there will always be two lines of symmetry. The one that slopes up to the right has a gradient of 1. The other one has a gradient of -1. And both these lines always go through the intersection point of the asymptotes. Now, in this case, it was a bit easier because the point where they went through is the y-intercept. And so we know both of these lines are going to be like that. Okay. So in closing, the lines of symmetry for this hyperbola are going to be y equals x -2 and y equals -x -2. And if you were wondering why we didn't sub in, we didn't sub in because we could literally see the y-intercept of the straight lines. However, if we did sub in, it would still work. There's nothing wrong with that. Okay. Give me a thumbs up if you're feeling okay. Give me a thumbs down if you're feeling like, oi, 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 this is a bit much. Okay. Just want to get a feel, because I've been talking quite a lot in my teacher land. It's nice to see how the people are feeling. And I know it can be tricky now. We're getting a bit harder. Okay. let's do, not going to do the whole question before the brain break. We're going to take a brain break soon, but I just want you to do 5.1 and 5.2. Once you've done 5.1 and 5.2, we're going to take a brain break. So let's just quickly get that down. So Nontokozo, don't worry. We're going to practice another question now with the line of symmetry. And so I know that this is new to you, so I'm going to give you lots of chances to see the line of symmetry come through. Okay.
Well, you guys are doing great.
Can I go back for a screenshot? Yes, I can very quickly. There is, take a screenshot now. Okay, 3, 2, 1. Okay.
Yo, this is on fire. They've already given us the X's and the Y's.
Yeah, the asymptotes is a nice, it's a nice easy mark, isn't it? But now let's find the X and Y intercepts too. Where x-intercept is a little bit trickier. And what's the y-intercept going to be like? How does that work? The y-intercept, we make x0. So we will just get, we have to solve this one. So the goal is to just get the x and y intercepts before we have our brain break. Let's see how it goes with that.
We can do it.
Yes, we can. So the x-intercept always seems to take a little bit longer than the y-intercept. Okay, see how I think I agree with you. Yeah. What about the x-intercept? What do we get for that? Watch out for, negative times a negative. That can always catch people out.
Check your signs, guys. Signs
Yeah,
are
watch out for the positives and the negatives. They can cause a bit of
yeah, especially when we're tired. We're just like,
oh. So I seem to get a -2/3 or -2/3 for my x-intercept, and I get -1 for my y-intercept. If I look at how I did these, give us a thumbs up if you got that. Thumbs down if you didn't. Okay. All right. So what we're going to do now is, if you need to take a screenshot now. We are going to come back and finish this question, but we've been going for quite a while. And so I want us all to be on our feet for a second. And I want us to pretend we're at Virgin Active and we're just warming up for our class. And so we are going to do a little stretch. And Yolanda is going to help us to feel
I'll be looking at everyone. Yeah.
So guys, stand up. Let's on your feet and let's just have a little stretch quickly.
I'm not sure, because of the load shedding, it looks like everyone is just on blank mode.
That's in my mind, I'll imagine fantastic stretching everywhere we go.
Yeah, me too.
I'm going to swing my arms around a little bit, make sure I don't whack something over.
Muzi, hope you're stretching. Lorraine. Melissa. Let's do this, guys.
Let's do it. Let's stretch it out. All right. And then once you've done a nice stretch, I want you to solve the social network mystery for me. Let's see what's possible. Okay, so everyone is pretty confident they know what's going on with YouTube. Let's see. I agree. It does seem to be that YouTube is obviously 7. Okay. Now, what about Facebook? Okay, so it does take a bit longer, but you're right. I agree. 9 times 7 is 63. And let me change my color. So 9 times 7 is 63, plus 9 is 72. So we have 9s. Now, the only thing we haven't dealt with is Instagram. And this is where our multiplication, basically knowing our times tables well, is very helpful. Now, it's obviously Instagram can't be a small number because it would never work with a small number. And so it has to be like, it can't be a 5, it's 6. So just keep going upwards and see what you get. So Cameron Mabalentle says 8. Dawn says 8. Let's see. 8 times 9 is 72. Plus 8 is 80. So I think I agree with you. That is a 8. So what is the final answer going to be? So BODMAS says 9 times 8 must happen first. So we have 7 plus 72, which is going to give us a final answer of 79. Well done, guys. Very good. Very good. I feel like That was a little bit harder today. I went to look for one that just wasn't too straightforward and too easy.
I think it was just about right.
Sarah, do you have a question? Do you want to raise your hand? Or is that just a... Okay, then let us get back to the hyperbola that we were doing. So we have mastered the first part of this question, and we've done the x and y intercepts. We've done the asymptotes. What I want next is I want us to write down the domain. And I also want us to sketch the graph. And then, in fact, sketch the graph. And then I want you to find the line of symmetry. And it says the equation of the line of symmetry, which has a positive gradient of 1. So they're telling you something. They're saying this because there's a y equals x plus k, not y equals minus x plus k. They're saying, find me the positive line of symmetry and work out the value of k. So over to you guys. I think we're going to finish off with this, or close to it, because I need to explain some changes that are happening for term 3. So let's push ourselves to get to the end here and write down the domain, sketch the graph, and find the line of symmetry for this particular one. Let's do it.
Guys, let's do this.
I'm going to write this down so I have a bit more space. So that was -1. And the x-intercept was down here. So I'll even draw it up here. X-intercept minus 2/3. And then I can give you some more space so you can see what's being written here. I see lots of domain and ranges coming in. That's good.
You guys are doing well. Let's go.
Yep. So can we draw our graph now? And can we work out one of the lines of symmetry? And if you have a question, don't be afraid to raise your hand. We would love to talk to you. Let's look here. Okay, later 1 2/3. And then this should be called the function f. And I should label my x-intercept and my y-intercept. So that one was -1, and this one was -2/3. So those are the two dots. What you want to do is sketch the graph, clearly show the intercepts with the axes. I've shown my intercepts with my axes. I've also shown my asymptotes, and notice how I've labeled my asymptotes. So that is drawing that. Now the last step is to go, can you find the equation if y equals x plus k is an equation of the line of symmetry? So that's going to be the positive line of symmetry. It's going to be that one over there, which cuts it in half. You have to find out the value of k. And the way you're going to do that is you're going to have to find out basically where this cuts, well, find the equation of the graph. And whatever the equation of the graph is, it's going to give you what's called the y-intercept, which is the k value that they're talking about. So let me give you some time for that.
We can do it. We are nearly there, guys. We are there.
So you could figure out both, guys. There's still two, but the question asks you specifically about the one with a positive gradient. Can you see where it says x plus k? It's almost like when they say that, they're saying y equals 1x plus k is the one we're interested in. And so that's why I'm only focusing on finding the one. Now, what's really important is this point where the two asymptotes meet, and the point that I can see is the point 2, 3. And so basically I know I'm going to have that equation, y equals 1x plus c, and I know that my straight line goes through the point 2, 3. And so that's going to help me figure out what the c value is. And the way this equation is written, the c value and the k value are the same thing. So basically you can see it's in that position there. That's what's going to tell us. Okay. So what do we get? So we sub this in, we get 3 equals 1 times 2 plus c. And then this 2 over here, when I bring it across, this positive 2 becomes a negative. So I get 3 minus 2 is c, which is 1, which means that k is equal to 1. And that basically means this thing over here has a value of 1. That's the y-intercept of the line of symmetry, the positive line of symmetry. The equation of the graph would be what of the line of symmetry would be y equals x plus 1. Okay, so guys, I hope that you're feeling a little bit better about lines of symmetry. If you're feeling okay about lines of symmetry in hyperbola, give us a thumbs up. If you're feeling still quite lost, give us a thumbs down. I just want to get a feel for the group. Okay. If I think about what you summarize, they're actually quite simple because you have to find the point where the asymptotes meet. Your asymptotes, it looks like you guys are all very comfortable finding your asymptotes. And then you have to just use straight lines, your understanding of straight lines, and the fact that the lines of symmetry only have gradients of +1 or -1. Okay, guys, what we're going to do now is we're going to call the learning part of tonight, well, I mean, the sort of content part of tonight, we're going to finish a bit earlier. And I want to explain some changes that are happening with Watobe going into term 3. So if you need to take a screenshot now. And then Yolanda, if you could just also get the quiz for tonight ready in the background. And then we'll discuss some of the changes that are happening in term 3.
It's ready.
Okay, so take those screenshots if you need them. All right.